Welcome back to Tree! We found a plant you're definitely going to be stuck on. This is Drosera capensis, the Cape Sundew. Look at it, sparkling, looking as adorable as a crystal chandelier in the plant world, but in reality it's a cold-blooded predator. In this video, we're going to watch how this 6.5 million year old plant turns unfortunate insects into a protein-rich lunch. Hit that like button and subscribe before you also get lured into this mysterious trap. Let's dive in! Drosera capensis, commonly known as the Cape Sundew, is not only one of the most popular carnivorous plants among collectors, but also a living testament to the marvelous adaptation of nature. This species, with its sparkling appearance and ruthless hunting mechanism, holds evolutionary secrets dating back millions of years. The formal discovery of Drosera capensis is closely linked to the botanical explorations conducted at the Cape of Good Hope, hence its common name, the Cape Sundew. This region, located in South Africa, was a biodiversity hotspot that attracted numerous European naturalists starting in the 17th century. Predation method, the sticky trap from the Cretaceous period. Its hunting mechanism is considered a prime example of a flypaper trap. The surface of the capensis leaves is covered with hundreds of small tentacles. Each tentacle culminates in a gland that secretes a thick, clear, sticky, and sweet liquid. This liquid is a combination of super-adhesive mucilage, a type of polymer, and digestive enzymes. The mild sweet scent and the sparkling appearance of the dewdrops in the sunlight attract small insects such as fruit flies, mosquitoes, ants, and small beetles. When an unfortunate insect touches even a single drop of the mucilage, it immediately gets trapped. The more it struggles, the more the mucilage stretches and adheres the victim to more tentacles. Once the insect is trapped, the nearby tentacles bend relatively quickly, within minutes, to enclose and firmly hold the prey. The tentacles further away on the leaf will also slowly curl inwards. This process can take several hours. With the prey fully enveloped, the plant secretes potent digestive enzymes to break down the soft tissues of the insect. The essential nutrients are then absorbed directly through the secretory glands on the tentacles. Once the digestion process is complete, usually taking several days, the leaf reopens, leaving behind the dry insect remains, ready for the next hunt. Drosera capensis is endemic to the Western Cape region of South Africa. This area is famous for its unique fynbos ecosystem, a drought-tolerant and nutrient-poor plant community. The natural habitat of capensis is typically peaty or moist sandy soil, which is very low in essential minerals, especially nitrogen and phosphorus. This is the primary evolutionary driver that forced the plant to seek nutrients from animals. Despite the nutrient-poor soil, it is consistently kept moist by rainwater or groundwater. Capensis often grows at the edges of swamps, seasonal wetlands, or areas with slow drainage. The plant requires direct sunlight or strong light to thrive and maintain the attractive red coloration that lures insects. Adaptation to this harsh environment is a crucial factor that has allowed capensis to maintain its ancient predatory form. Drosera capensis is a perennial species, meaning it lives for multiple years. However, its growth habits vary depending on environmental conditions. In cultivation and many native areas, D. capensis grows continuously without a distinct dormancy period. It produces new leaves from the plant's crown on an ongoing basis. Over time, as the older, lower leaves die off, the lower part of the plant's stem can elongate and become slightly woody, forming a small trunk. This helps the plant elevate itself, sometimes resembling a small palm tree. A characteristic that differentiates it from many other ground-hugging Drosera species. C. capensis is well known for its strong asexual reproduction capabilities. It can naturally produce plantlets from its roots. When roots are damaged or severe, they have the ability to regenerate into new plants easily. This is a major evolutionary advantage, ensuring the species' survival under potentially disturbed environmental conditions. For a plant species that relies on insects for nutrition, pollination presents a significant challenge. How does the plant attract pollinating insects without turning them into a meal? Drosera capensis has solved this problem through an effective spatial separation mechanism. The plant develops a tall, slender, upright flower scape that can extend up to 30–40 centimeters above the trapping leaves. This distance ensures that pollinating insects can safely access the flowers without becoming entangled in the sticky tentacles below. Capensis flowers are typically pale pink or white and tend to self-pollinate if cross-pollination does not occur. The flowers open sequentially along the scape, remaining open for only a few hours during mid-morning or early afternoon, after which they close and form seeds. After pollination, the plant produces a large number of tiny, dark, dust-like seeds. These seeds can be easily dispersed by wind or water, completing the sexual reproduction cycle. And that's everything we had to uncover about Drosera capensis, the plant species that has perfected the sticky hunting art for 65 million years. I hope you truly got stuck on this video. Personally, I think there's a clear message here. Don't trust everything that glitters, especially if it's a leafy plant covered in gooey goo. Be careful. If you ever see a crystal chandelier out in the swamp, remember the tree warning. Thank you for watching. See you in the next video. Always stay curious and steer clear of overly sweet dewdrops. Goodbye for now.